Let us look at proposition number 4 of book 11 of Euclid's Elements. The proposition says, if a straight line is set up at right angles to two straight lines which cut each other at their common point of section, then it is also at right angles to the plane passing through them. So what the proposition is saying is, if a line is perpendicular to two intersecting lines at their common point of section, that is this point, then this line is also perpendicular to the plane in which these two intersecting lines are. Okay, let's see how we can prove this. See, first thing that we will do is, let's mark a point on this vertical line for reference. And let's hide off that line. Okay. Now let's cut off equal segments on these two lines across this point of intersection. Let's mark this point of intersection as E. To do that, let's draw a circle of any radius. So now with the center E, now let's mark these points of intersection. So now remember, because they are the radii of the same circle, AE is equal to BE is equal to CE is equal to DE. And now we actually don't require the circle. Now let's join AD and let's join BC. When we do that, you will notice that this triangle ADE and BCE, they are congruent. How? Because angle AED is equal to angle BEC, vertically opposite angles. And we know AE is equal to B, B is equal to C. So side angle side. Using that proposition, we can say that these two triangles are congruent. Now, since these two triangles are congruent, that means angle DAE is equal to angle EBC. These two angles are equal. Let's take a random point on AD. This can be anywhere. And from G, let's draw a line through E passing through BC. Let's mark this point of intersection as H. Angle AEG is equal to BEH. Why? Because vertically opposite angles. So we have this angle is equal to this angle and this angle equal to this angle, and we know AE is equal to BE. So that means triangle AEG is congruent to BEH triangle, which means AG is equal to BH and GE is equal to HE. These two sides will also be equal because they are congruent. Let's join AF and BF. Now here, angle FEA and angle BEF, they are right angles. That means they are equal. Because remember, we started off by saying AB and CD are intersecting lines on which at the point of intersection we are drawing a perpendicular line, EF. So now again, this triangle is going to be congruent to this triangle. How? AE is equal to BE. EF is a common segment or common side, and these two angles in between these equal sides are equal. So side angle side. So these two triangles are congruent. Now if these two triangles are congruent, that means AF is equal to BF. Now it may not look like that because we are looking at it sideways. If I rotate it, you will notice that it is equal. Yes. So you have to be careful. Similarly, we can show if we join DF and CF that these two triangles are also congruent, which means DF is equal to CF. Remember, we have already concluded AF is equal to BF, CF is equal to DF, and AD is equal to BC. That means these two triangles are also congruent. So if these two triangles are congruent, it means FAD angle is equal to FBC. So if I rotate it, it will become clear. No, I'll have to hide those angles now. Okay, now I think it should be clearer. Yes, these two angles are equal. And let's join FG and FH. So now FAG is congruent to FBH. How? Because this angle is equal to this angle, AF is equal to BF, AG is equal to BH. So since they are congruent, we can say FG is equal to FH. Now, now let's look at triangle FEG and FEH. You will notice that we have proved that FG is equal to FH, GE is equal to EH, and FE is common. So that means these two triangles are congruent. And since they are congruent, it means that the angle FEG is equal to FEH. And very importantly, you will notice that these two angles are on a straight line. So their sum will be 180 degree. And since they are equal to each other, that means both of them will be right angles. So angle FEG is equal to FEH. And remember, these are random point we took. So if we take any other point also, the same conclusion we arrive at, that these are right angles. We have already seen that if FE is perpendicular to all the straight lines which meet it at right angles and are in the plane of reference, then we can say that FE is perpendicular to the plane of reference. So that is proposition number 4 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.